All right. So the next module, module 3, there's a lot of information in this one. We are going to be talking about in chapter 4, if you have your book, everything about rationals. So all those ideas that look like fractions. So chapter 4 is a lot of fractions, polynomial style. So we're definitely going to be talking about that. So you're definitely going to get some fraction work in here. Although the calculator isn't going to be too much of a help too with this because we are doing polynomials within these fractions. So it's going to make things a little bit different than what you've experienced before. And then when you get into chapter 5, you will be talking about radicals and things like that. So we're going to take those two cases when we talked about domains. As you can see, we're going to be the first thing we're going to talk about in here, that when we talked about domains of functions, remember we always assumed that everything was all reals unless we had rationals or radicals. And so that was my review. That was right here. Remember, domain is all about x values. We always assume it's all reals, which means it's negative infinity to positive infinity, unless we had these two cases, rationals or roots. Again, since we are in chapter 4 right now, we are not going to worry about the roots. Okay, so that's why there's a big X right there. But how do we find the domain of rationals? Hopefully you remember. If not, you can always look it up. But if you said take the denominator, set it equal to 0, and solve, you're absolutely correct. Remember, rationals, they look like fractions. Okay? So this P of X over Q of X, what this P of X and this Q of X means, that means that those are polynomials. Okay? We talked about polynomials a little bit. But they're polynomials like x squared plus 3x plus 7 or x squared minus 81, stuff like that. Those are polynomials. Even the cubic functions that we were factoring in 3.6 at the end of the last section, module 2, those are polynomials as well. So all we got to do is set the denominator equal to 0 and solve. I will tell you, in chapter 4, what we're in right now, for module 3, chapter 4, you need to have your factoring skills down pat. I have provided videos for all the factoring from 3.5 and 3.6 in the announcements. Okay, so if you need to review factoring, go check those out. All right, so let's get started. So right here, I've got a rational, because again, that's what this section's about, rationals. I want to find the domain. So all we're going to do, take that denominator, set it equal to 0. Again, we don't care what the numerator's doing. We care about the denominator, okay? Because we cannot have 0 in the denominator. So we got to figure out what those numbers are that create 0 for us down here. So we add 5 to both sides, and we find out that x is equal to 5. So remember in class when I talked about this, this is the number that we throw out. This is the friend that we do not invite to the party, because remember, this is that drunk friend, and we don't want to invite this drunk friend because they're going to ruin the party and we're going to end up having to take care of them. We want to have a good time. We want everybody to come to this party but this person, because they're going to spoil everything. Now remember how we write this up. There are two ways to write this up. You can write it up as set notation. So remember, set notation is pretty easy to do. All you do is you put your little embellishments, the X with the X bar, and then your braces on both sides. And then all that goes in the middle is the numbers that we're throwing out. In this case, it's X equal to 5, and you put a slash through the equal sign. And that's how we do set. Okay, it's basically you just take this answer, put a slash through the equal sign, and put the embellishments around it. When it came to the interval notation, we start at negative infinity with a parenthesis, and we move up to our problem number, which was 5, and then we jump over it with a parenthesis, union parenthesis. And then we pick right back up on the other side with that 5 and move on towards positive infinity. And that was how we dealt with interval notation. Again, this piece right in here in the middle, that's just like means that we're jumping over the number. Okay, so we jump over the 5 and we pick right up on the other side of 5 and move on towards positive infinity. All right. So what do you think about this? You guys got this? Give it a shot if you think you do. Pause the video now. For those of you that didn't pause the video, let's talk about this. Again, just because we have 2 parentheses down here doesn't change a thing. It says in order to find the domain for this, we take the denominator and we set it equal to 0. So I'm going to take that denominator and I'm going to set it equal to 0. Now, some of you normally in class, I would ask how will we solve something like this? And some of you would be like, let's FOIL this thing back out. And I'm going to be like, no, don't do that. Because if you FOIL it back out, you are undoing all the great work that has happened for us, because right now this thing is factored. And we love factored rationals. Okay? So don't FOIL this back out. What I need you to remember is back in algebra, we had a special property. It's called the zero product rule. What the zero product rule says is that if you have 2 things that are being multiplied and they equal 0, one of these 2 things has to be 0. Okay? That's what we're going to apply in this situation. I have 2 parentheses that are multiplying to be 0. Well, one of these parentheses has to be 0. Which one is the 0? I don't know. So we're going to set both of these equal to 0. And that's how we're going to know what x equals. It's called the zero product rule. So one of these 2 parentheses has to be 0. Which one is it? I don't know. So that's why we set them both equal to 0. So we subtract 3, x is equal to a negative 3. So there's one of the numbers we're going to throw out. Add 2, x is equal to a positive 2. There's the other number we're going to throw out. Okay? So if we write up the domain to this, set notation would look like this. Again, our embellishments. And then all we do is we put these 2 guys that we just found, x equal to negative 3, put an or, x equal to 2 inside, and then don't forget to put a cross through the equal sign, because we do not want these numbers. If we were doing interval notation, it would look like this. We start at negative infinity. What's the first problem number we reach? Negative 3. And we jump over it. We pick up on the other side at negative 3. And we continue along our journey of inviting people. What's the next problem number we don't want? 2. Oops. My pen's not working for a second. 2. And we jump over it because we're not inviting them. And then we continue along our journey and there are no more problem numbers, so we shoot off towards infinity. And there's what it looks like. This idea right here, it just keeps expanding depending on how many numbers you're throwing out. So like if I had a 5 that we wanted to throw out, then in here I would have a parenthesis of 2, comma 5, parenthesis, union, parenthesis 5, comma infinity. I just keep adding in parenthesis, union, parentheses as I jump over the numbers I don't want. Okay? And that's all you do to find the domain of these things. Okay? This is just review. We've done this. We've done this. All right. Try it again. Pause the video now. Give this a shot. Okay. So this is just like the last problem. The denominator's already factored. Fabulous. So all we got to do is we got to set the denominator equal to 0 and solve. Okay? So since this is factored using the zero product rule, x plus 7 equals 0. x minus 5 equals 0. So over here, x is equal to a negative 7. We're going to throw out negative 7. X is equal to a positive 5. We're going to throw out the positive 5. So if we write out our domains, set notation looks like this. Our embellishments with x not equal to negative 7 or x not equal to 5. Now, I know some of you are like, Mr. Armstrong, does it matter the order on these two? I usually put them in order, the smallest number to the largest number, but it really doesn't matter. But as a mathematician, I'm used to putting stuff in order. Interval notation, we start at negative infinity, and we work up to a negative 7. That's the first problem number. And we jump over it. And we pick up at negative 7, and we move up to a positive 5. And then we jump over it. And from positive 5, we work up to a positive infinity. And there is the interval notation. Cool. All right, I got one more of these. Give this one a shot. Pause the video and go. So how'd you do? So hopefully you noticed that the denominator is not factored. You need to factor in this. If you didn't factor, you wouldn't get to the answer. Okay? So again, to find the domain, we just set the denominator equal to 0. And now you factor this. Because we are in section 4, I am not going to show all of the factoring. I need you to be good at factoring now. If I had to go through and show all the factoring work, these videos would be even longer than what they are. Okay? So this guy, you would use either AC, slide and divide, the box method, guess and check. It was your choice. And this guy would factor out to be x minus 5, x plus 4. And now that we have it factored, we can set each one of these equal to 0 because of the 0 product rule. And we find out that we want to get rid of a positive 5 and a negative 4. Okay? So, domain, then, set notation, x bar, throw out a negative 4, or, oops, running out of space, or we're going to throw out the positive 5. Interval notation, start at negative infinity. First problem number we come to is negative 4. Jump over it. We're picking up on the other side of negative 4. Next problem number we come to is 5. Jump over it. Pick up on the other side of 5, and we shoot off to infinity. And there you go. That's how we find domains. Again, this was just a review of stuff. All right. Next that they want you to do in 4.1 is they want you to be able to evaluate. So remember that when we were evaluating using function notation, whenever you had a number inside the parenthesis, that represented x. Whenever you had the function notation equal to a number, remember that f of x, that was just a fancy way of saying y. Okay? Go ahead and give these problems a try. We've done this. This isn't new to us. Okay? So again, this is just all review of what we did back in chapter 1, module 1, but except we're just focusing in on rationals. Pause it, give it a shot. Okay, so because this 0 is inside the parenthesis, just remember that that's x. So all we're doing is we're plugging 0 in for x, and we're going to kick out the number. Okay? Well, 0 is on top. On the bottom, 0 plus 2 is 2. What is 0 divided by 2? And that answer is 0. So there you go. There's the first answer. When x is 0, f of x is equal to 0. So for the next guy, again, they give us a value here of 4. So we're going to take that 4, we're going to plug it in. Wherever the x's are, put a 4. And then now we just, do a little PEMDAS and simplify stuff down. So on top, we got a 4. 4 plus 2 on the bottom is 6. And they do expect you to reduce your fractions. Okay. Remember, I taught you how to use the calculator to reduce your fractions. So you can use that calculator, reduce these fractions. You got this. And if you plug that into the calculator using your alpha y equals, you get 2/3. And there you go. And there's the answer. For when x is 4, f of x is equal to 2/3. Now this guy over here, a little different. I can understand if you had problems with this one, but let's talk this through. Here, we are telling you that y is equal to 6. So we want to take the 6 and put it in the y position, which is right here. So you have 6 equal to x over x plus 2. All this is a proportion. How do you solve proportions? You cross multiply. How do I know it's a proportion? Because this 6 has a number under it. It's 1. Cross multiply, ladies and gentlemen. So all we got to do is take the 1 times x, and that's x, equal to, we're going to take the 6 times all of that x plus 2. So it needs to make sure that you distribute through on that, okay? So 6 times x is 6x. 6 times 2 is 12. And then you just keep solving, continue solving, get the x by itself. So I'm going to take this 6x and move it over here to the left side by subtracting 6x, subtract 6x. Remember that there's a 1 in front of this. So 1 minus 6 is negative 5x equal to 12. And then now all I got to do is divide by a negative 5 because that's how you get rid of multiplication. And you now know that the x value had to be a negative 12/5. And there you go. So in this last problem, they gave you the y value. You plug the y value into the y spot, and you're going to do some cross multiplying and solve the proportion. That's all it is. Okay? All right. Now for the big part of section 4.1. This is the huge part right here. I need you in 4.1 to become rock stars at simplifying rationals, okay? Because you got to use this skill all the way through 4.2, 4.3, 4.5, okay? And 4.4. You have to be able to simplify. All right. So let's talk about simplifying. Basically, when you reduce fractions, you are doing simplification, okay? So take that fraction, let's just take 4/6. What makes up 4/6? Well, 4 is made up of 2 times 2, and I'm talking about the prime factorizations. And 6 is made up of 2 times 3. Your calculator, when it's reducing, it's thinking about this information. It's looking at the prime factorization, which is what we have here. And if you notice in here, what do both the numerator and denominator share in common? The 2 that's in front here, this guy. So what happens is when you have 2 over 2, they cancel out. And what does that leave you with? 2/3. And that's what 4/6 reduced to. That's the same kind of simplifying we need to do here, but we're going to do it polynomial style. We're going to take out what is in common from top to bottom. Okay? So when we look at first the 6 over the 24, and that's the only thing I'm going to concentrate on. Okay? How is 6 made? Well, it's made by 2 times 3. How is 24 made? Well, it's made by 2 times 2 times 2 times 3. Okay? That's the prime factorization for 24. It's 2 times 2 times 2 times 3. Okay? Now, looking at your variables. Up top, I have x to the 5th. Well, what does x to the 5th really mean? What does it really mean to be a power of 5? It means that I have x multiplying itself 5 times. Okay? Down below, x squared, what does that really look like? X times x. Okay? So there's what we know. All right? So when we look at this, what's in common from the top to the bottom? Well, I've got a pair of 2's right there that are in common. I've got these 3's right here that are in common. I've got this x and this x and this x and this x that are in common. All those things that are in common that I just circled, they're going away. So what is it that I have left on top? I have x times x times x, which is x to the 3rd. And on bottom, I have 2 times 2, which is 4. And that is a simplified answer. Now, I know what you're thinking. You're like, Mr. Armstrong, do I got to do this for every problem? No, I'm showing you what's really going on behind the scenes, because I'm going to use this kind of context of what matches from the numerator and into the denominator a little bit later on. And then, so I want to show you some things. Again, with this right here, you could have just gone to the calculator and put 6 over 24 in and reduced that down. Okay, so put the 6 over the 24 and there, that reduced your numbers, which would have been 1/4, which you can see in here. There is an imaginary 1 in front of this x cubed. Now, when it comes to your variables, I call this a battle whenever I have variables next to a number like this. So in the battle, x's are going to take out 1x for 1x, as you saw down below. So in this battle, who has more x's? The numerator. Hence why my x over here stayed in the numerator. See, and you see 3 x's left in the numerator. Okay? So what you want to do in a battle is, between your two variables that are in common, whoever has the bigger army, that's where the variable will stay. Since this guy was the bigger one, that's why my variable stayed in the numerator. And then all you got to do is subtract those two. Look, 5 minus 2 is 3. Oh, that's the answer I got right over there. So I call this a battle, okay, of armies. Who's bigger? The numerator was. That's why it stays there. And what's 5 minus 2? 3. So that's a quick way that you can do some simplifying. So go ahead, pause the video, try this one on your own. All right. So if you went into your calculator, you can quickly reduce this, and you found that it was 7 over 3. Okay? Because on top, you had 7 times 7, and on bottom, you had 7 times 3. Okay? So the 2 7s in front canceled out. There's the 7/3. All right. So now if you look at everybody else, we've got a battle between the x's here. Any x or any variable that doesn't have a power, it really does have a power. It's a power of 1. So it is right there. Okay? So there's a battle between x's. Who has the larger army? The denominator. So my x is going to stay down here. How many people are left in the battle? Well, what is 7 minus 1? 6. So I have an x to the 6th. Let me clean that up so it looks more like x to the 6th. Perfect. There we go. All right. And then now, if we look at the y's, they have a battle. Who has a larger army? The numerator. So y will stay up here. What's 8 minus 3? 5. And there you go. That is now simplified. All right. Give this one a shot. Have a little problems? Okay. Something a little weird here? Yeah. This is different. Okay. This is why I said you got to make sure that you're good at factoring. Because from here on out, you got to make sure that numerators and denominators get factored before that final answer, because we have to check for canceling. Okay. So when we look at this, you can't just come in here and try and cancel the x over the x's out and then the 2 over the 4 and say that, oh, well, that's a 1/2. You can't do that. Reason why we can't do that is because of the addition signs right here. This 2x is with this 14 because of that addition sign. They're all stuck together. It's like a giant family. The only way you're going to take this family out up here, the 2x plus 14, or vice versa in the denominator, the only way you're going to take out this 4x plus 28, because these 4x and the 28, they are together, is if it matches the same in the top. So if up here I had a 2x plus 14 and a 4x plus 28, do you see how this guy matches that guy? I can take those out now because they match, and I'm canceling it all out because that addition sign, and if it was a minus sign, it's the same thing. These means that this is a giant family. If you're going to try and take out one person in the family, you got to take it all out. Okay? So that's why we can't just cancel the x's and simplify the 2 over the 4 to a 1/2 and the 14 over the 28. We can't just do that. It doesn't work like that. Okay? Because of the addition, and if it was subtraction, the same thing, they're a family. If I want to take out the 2x, I got to take out a 2x plus 14. I got to take out all of it. All right. So that means we now need to look at factoring. So remember, the first line of defense in factoring is a GCF. If you look at this numerator, there's a GCF in it. You need to pull that GCF out. You've got to remember all of your factoring, ladies and gentlemen. You have to remember that because that's the only way that you can simplify. Okay? So there's a 2 that can come out of the top because that is the largest number that will divide both of those. And that will leave us with an x plus 7. Okay? Then we look in the denominator. What number can divide both 4x and 28? And you are correct with a 4. A 4 can divide that. And when we pull that 4 out, we get x plus 7. Now we can look at crossing stuff off. Is there anything in common from the top to the bottom? Absolutely. These x's can now cancel out because I'm canceling out the whole x plus 7. See how it matches from top to the bottom? These two match, so I can cancel all of it out. I took out that entire family. Yay! And then over here, now look what you got left. You just got 2 over 4. Well, you know that can reduce down to a half. And that's the answer they're looking for on this. Now, when you put your answers in, I meant to talk about this a moment ago, but when you put your answers in, most of these are looking for, like, basically it'll have a line and then a blank and a blank. And you're basically just filling in the numerator, telling us what it is, and then the denominator, telling us what it is. Okay? If they don't give you 2 blanks for it, if it just gives you a plain old blank, remember that there is an arrow that you can select right over here. It's usually yellow. I can't remember if it points down or if it points up, but that opens the equation editing tools. And in the equation editing tools, you have a symbol that looks like this, that looks like a fraction. You press that fraction, and then you'll be able to put in the answers. You'll be able to fill in the top box. You'll be able to fill in the bottom box. And that's what they want up in here. Okay. Use that equation editor to help you out with that. Because it will allow you to create the fraction. All right. So I have some more here. So go ahead and pause the video and give this one a go. Okay, so in this guy, Again, you can't just cancel out the x squareds. You can't just cancel out the x's because you want to. I mean, I know it's very, very tempting because they are the same from the top to the bottom. But remember, you got all this addition and subtraction going on. This is one giant family right there. If I want to take out x squared plus 2x minus 8, I got to have an x squared plus 2x minus 8 down here on the bottom. And vice versa. If I want to take out the x squared plus 9x plus 20, I got to have an x squared plus 9x plus 20 up at the top to take it all out. It's a family. If you're going to take out a family, you got to take them all out. Okay? But what we can do is we can factor all of these factors. And again, this goes back to the AC method, the slide and divide method, guess and check, the box method. These are trinomials, so you factor them like trinomials. Again, I can't show all that work because we don't have time for that in this unit to show that. And plus, that would make these videos extremely, extremely long. Okay? So up here, this top guy, this numerator, factors to x plus 4, x minus 2. The denominator factors to x plus 4, x plus 5. So, is there anything in common from top to the bottom that can cancel out? Absolutely. The x plus 4's gone. What do I have left? X minus 2 over x plus 5. And done. That's all it takes to simplify. Cross off what's in common from top to bottom. Okay? Pause the video. Give this one a shot. So hopefully when you looked at this one, hopefully, again, you're going through those steps as I taught you. What is your first line of defense in factoring? And that is a GCF. I believe this one will factor if you don't pull out that GCF, but you really do need to pull that GCF out. If you did not pull the GCF out of this one will not factor no matter what you do. That's why I always told you when it came to GCFs, it's very important that you look for those first because sometimes stuff will not factor if you do not pull it out. Okay? So up here, what is in common up here? Well, all of that can be divided by 2. So if I pull a 2 out of that, I get x squared minus 10x plus 25. That is a heck of a lot easier to factor than when you were dealing with this guy from the very beginning. Down below, if I pull the 3 out, that gives me x cubed minus 125. And now you're not done, because everything that's left in these parentheses can still factor. So up top, you get x minus 5 and x minus 5. I would not say that the top is 2x minus 5 squared, even though that is correct. You're going to want them both written out because you want to see stuff that can cancel out because it's a 1-for-1 type action. Okay? So I would hesitate to condensing them down like this. Oh, come on, eraser. There we go. Now the denominator factors because it is a cubic. Okay? So the denominator factors because it is a cubic. And remember, when you do the cubic, you take the cube root of the first term, which is x cubed. So that's x. So that's your a. One time I kind of review factoring with you, partly because this is kind of new to many of you. And then we take the cube root of the second term, which was the 125, and that's 5. And that's the b. Remember, since this is a difference of cubes, that a difference of cubes factors with a minus b, and a squared plus ab plus b squared. Okay? So that's how a difference of cubes factors. So if we factor this guy out down here, we get x minus 5. And then we have x squared plus 5x plus 25. Now this is fully factored. Now we can look at what's going to cancel. And is there anything in common from top to bottom? Absolutely. This x minus 5 and this x minus 5 are going to cancel out. And that's it. What do we have left? We have 2 x minus 5 all over 3 x squared plus 5x plus 25. If you want to, this answer is perfectly valid, but if you want to, sometimes people like to actually FOIL everything out and get what the real polynomial or rational was. So people would distribute the 2 through the top and get 2x minus 10 and put that over and take the 3 through the parenthesis down below. So 3x squared plus 15x plus 75. Both of these are valid answers, whether you input the factored form or the actual FOILed out form. Both are valid. I think I have one more. Yep, this is it. So pause the video, try this one. Okay, so up on top, notice there's nothing really to factor, so we just got x minus 9. Down below, this is a difference of squares. So you get the x minus 9 and the x plus 9. Now notice, when I ask, is there anything that's going to cancel out? Well, these two almost can cancel each other out. The problem is that this guy is opposite signs compared to what's down here. Okay, so when you have two families that want to cancel each other out, but the problem is one of them is the opposite signs, then that really meant that there was something we probably could have pulled out of this guy to make them match. What can we pull out up here to change this positive 9 into a negative and the negative x into a positive? In other words, I want to switch the signs. What could we have pulled out? Well, remember that if you want to switch signs, all you need to do is pull out a negative, and that will switch all the signs. So that's why I put this one in here, because sometimes you'll have two families that are really, really close that want to cancel out, but they can't because they're opposite signs. But now that I pull that negative out, boom, gone. What do I have left? I have a 1 over x plus 9. Simplifying, super, super important for us. Got to make sure that you understand this. And that is 4.1.